In this video, I'm going to go through the solution to question 28 from the 2025 Australian Math Competition Senior Paper. A cube of side length 10 has volume 1000. Points P, Q, R, S, T, and U are midpoints of six of the sides as shown or in a common plane. The vertex V of the cube is equidistant from these six midpoints. And what is the volume of the hexagonal pyramid P, Q, R, S, T, U, V? Okay, so let's focus on this front face that's facing us. Let's see what we can get. Because it's a cube, we have a square, right? And this top right corner is V. U and T are the midpoints, and they form sort of a triangle like this. The side length is 10, which is why these two become 10, and because they are midpoints, 5, 5, 5, and 5. And of course, we have right angles in a square, so we can use Pythagoras' theorem now. So we have TU squared is 5 squared plus 5 squared is 50. So TU is the square root of 50, which is the square root of 25, and the square root of 2. Square root of 25 is 5. And then what? UV squared and TV squared should be the same thing. They're equal to 5 squared plus 10 squared, which is 125. So we get UV and TV. They are equal to the square root of 125, which is the square root of 25 times the square root of 5. 5 square root of 5. So in our cube here, we have 5 and 5. This length here is 5 root 2. And this length here is 5 root 5. Okay. Now that we know TU is equal to 5 square root of 2, we can do a bit of analysis on the base of this pyramid. So the base, which is this hexagon PQRSTU over here, let's take a look at that. So the base of this pyramid is going to look something like that. PQRSTU. By symmetry, this is a regular hexagon with side length 5 square root of 2. So what I can do is I can actually split this up into 6 different equilateral triangles. They're not different, they should have the same area. So how do I work out the area of that? Notice that in an equilateral triangle, you can draw out the midpoint. It's also the angle bisector and the altitude. If this is x and this is 2x, then the length of the height is the square root of 3 times x. So think about that. Right now, 2x is equal to 5 root 2, so x is 5 on 2 root 2 right now. And this is square root of 3 times x, so the length of this side is square root of 3 times 5 on 2 root 2. And that is going to be square root of 3, square root of 2 is square root of 6, 5 root 6.2. That is the height. Now we're going to look at just one single one of this triangle, okay? So what's the area of the equilateral triangle? Well, that's half times base times height. So half times the base, which is 5 root 2, times the height, which is 5 root 6 on 2. So we have, on the numerator, 5 times 5 is 25. Root 2 times root 6 is root 12 over 4. But root 12, the square root of 12 is the square root of 4 times the square root of 3. The square root of 4 is 2, so the square root of 12 is basically 2 times the square root of 3. So that 2 cancels out with the 4 on the bottom. 25 square root of 3 on 2. And from there, we can see that the base area is just 6 times the area of each triangle because there's 6 triangles in the base. 6 of the 2 cancel. We get 3 times 25 square root of 3. That's 75 square root of 3. So we've worked out the area of the base of the pyramid. Now, what do we have left? We have, well, we still have to work out the height of the pyramid first. So, noticed here that QT, we have to work out what that is. Maybe focus on this triangle QVT here because they are opposite corners of that hexagon, and the altitude of that triangle is going to be your height. Okay. So, what is QVT? This triangle here. We know that QV and VT, they're the same thing as UV, which is 5 square root of 5 we have here. So these two lengths are 5 square root of 5. And then we know the height of this. Let's call that H. The height of that triangle is equal to the height of the pyramid. But what is QT? We don't know what QT is. How do we work that out? Imagine if I took the midpoint of that back edge over there and I draw that triangle with QT. What is so special about that? Think about slicing that cube exactly on the midpoint through QT. The cross section would be exactly half of the square there. Simply think of half of this square, half of that square, and exactly halfway between them is this one with QT. So, QT is just this triangle in the middle, and it's an isosceles right triangle, which is 10 and 10. So if this is 10 and 10, QT has to be equal to 10 square root of 2. So that's what QT is. And because this is isosceles, both 5 square root of 5 here, these two are equal as well. And QT is 10 square root of 2, that's 5 square root of 2. Okay. And again, I'm going to use Pythagoras' theorem. So I've got 5 square root of 2 squared plus h squared is equal to 5 square root of 5 squared. 5 square root of 2 squared. 5 squared is 25. Square root of 2 squared is 2. 25 times 2, that's 50. Plus h squared. 5 square root of 5 squared, that's 25 times 5, 125. So h squared is 75. H will be equal to the square root of 75, which is the square root of 25, which is 5, times the square root of 3. Okay, now we can work out the volume of the pyramid, right? The volume of the pyramid, the formula is 1/3 times the area of the base times the height. So we know the area of the base, we just worked that out. It was 75 square root of 3. and the height is 5 square root of 3. Okay, the square root of 3's actually cancelled out because 2 square root of 3's multiplied together give you 3. That cancels out with the 3 in the denominator, and that becomes 75 times 5, which is 375, which is the volume of the hexagonal pyramid. And we are done.